Hello everyone, let's start with the video. So in this video I'll be solving lead code problem which is from biweekly contest 161. So problem number is 3619 and it says count islands with total value divisible by k. So let's try to understand what it's saying. You are given an m cross n grid, got it? So they've given m cross n grid and a positive integer k. An island is a group of positive integers. Okay, they're saying positive integers representing land that are four directionally connected horizontally or vertically. Okay, so if you consider 5, so they are connected via 2, 0, 0, 0, this way, like four directionally. The total value of an island is the sum of the values of all cells in the island. Okay, if you consider this island, what is the total value of the island? It will be 2 plus 1, 3 plus 5 is 8. So yeah, now what they're saying is return the number of islands with total value divisible by k. Okay, so if you consider this island, so its value is 8, and if you try to divide it by k, which is here 5, so it is not divisible. So basically we'll have to find the number of islands, and we'll have to find the sum of the each cell in an island, and then we'll have to divide it by k and check if it is divisible. Then we'll have to uh, increase the count like we have got it, or else no. So let me try to explain you. So what they're saying is zeros are basically considered here as water. Zeros are considered water, and a positive integers, whatever we have here, positive integers are considered as land. So now if you try to see, this is one island because it is surrounded by water. Here also you can think of it is surrounded by water only. All these are surrounded by water. So this is one island. If you try to sum each cell value, so it will be 3 plus 5 is 8. So it is there, and k value they have given is 5. So if you try to divide, so you will get remainder as 3. So it is not a divisible, not a this island is not divisible by k. So this is not in our answer. Now let's try to think of this island. We have this island, right? So 1 plus 4 is 5, plus 1 is 6, plus 2 is 8, plus 7 is 15. So this island's value is 15, and if you try to divide it by 5, so remainder is 0, which means it is perfectly divisible, and this island will contribute to our answer. So our answer here is 1 for now. Now let's take one more island. uh, Islands are connected vertically or horizontally. They're not connected diagonally. This one you can think of connected, but it is not according to the question. So this is one more island whose value is 8. If you try to divide it by 5, so remainder will be 3. So it is not a perfect divisible of 5. So we will not consider in our answer. And now if you consider this island is again separate. So its total value is 5, and if you divide it by 5, its remainder is 0. So again this is in our answer. So in this case our answer will be 2. Yeah, as given the answer is 2. If you consider second example, all are having 3 values and k is 3. So if you try to consider this island, this is a separate island, 1 2 3 4 5 6, so answer is 6, because 6 islands we have and all island has value of 3 and it is perfectly divisible by 3. So how do we solve this? So what we'll do is we will go through all. This is basically a graph problem, uh, graph in a matrix we can think of. So we'll basically go through all the each cell, and we'll find that in each we'll go to this cell. This is water. We will not do anything. We'll move to the second cell. We'll come here. We'll see this is having a positive value, which means it is a land. So we'll try to find all the lands, I mean all the soils that is connected to this one. So we will find now this thing. This island will completely will find it, and by doing that, we will be returning the sum of these values. Okay, and we'll keep one more visited vector, which will keep track of not visiting this same island one more time. So we'll do that. So some value whatever we will be getting, so what we'll do is we'll try to divide it by 5. If it's perfectly divisible, then this is our answer, or else no. So now we'll go to again this island. Since this island has visited this one, because we'll be visiting first upwards, rightwards, downwards, and leftwards. So whenever moving to here, so we are visiting this. So once we have visited via 2, so we'll keep track of visited. So this is visited, and once we are done with this summation, and once we return back, so whenever we call the next cell, uh, we'll check if that is already visited or not. But in our case, it is already visited, so we'll move to the next cell. This is water, will not do anything. We'll move to the next cell. Again, we'll move to the next cell. Now when we are moving here, again it is visited via 2, so we'll move to the next cell, here next cell, and this finally will come here. Whenever we come here, so now we'll do again same thing, like checking diagonally, or vertically and horizontally, whichever cells are connected, and we'll return the answer. Now in this case also we'll be returning 5, and this is perfectly divisible, so this will contribute to our answer. We'll move to here, this is water, we'll move to here, this is water. Whenever we come here, so we'll try to move up. This is water, will not do anything, will not go. This is water, will not go. This is land, will go here. So we have came here. Now from this land we'll try to move up. This is already visited because we have visited already. We'll mark visited as true for this cell. So we'll not move here. We'll move to the right. We'll come here again. We'll try to move to up. This is water, will not go. This is water, will not go. This is water, will not go. We'll come left side. But this is already visited, so from here we'll come back. So yeah, again from 4 down we have water, we'll move left. From here we'll move up, but here we have water. Right side we have already visited, we'll move down. Okay, so I think you are getting pretty much how we'll do this. We'll keep track of visited array, and let me show you on the board, on the laptop, how to code this up. So first thing first, what we'll do is we'll take m. M is basically grid dot size, which is number of rows. We'll take n, which is basically number of columns, which can be found using grid of 0 or any 1 2 3 we can take off, but I'll be considering 0 because I'm considering at least there will be one row. So yeah, we have taken this thing. Now we'll take two vector whose type is boolean, because it is a visited vector whose rows are m, and whose columns are n columns. Basically the same vector, same grid size visited vector will take. Now what we'll do is we'll try to visit each cell one by one. So we can do this way. This is basically we are moving from row wise, and this is one particular row we have chosen. Now we are moving in that particular row, we are moving to the particular columns, all columns from 0 to n. One thing we'll have to check is that first grid of I, comma j has to be greater than 0, which means it is a land. If it is a water, will not be moving, because the question what they will ask is you will have to find the island ka sum. So so for that water, if you take that is useless. And at the same time, we'll have to choose one more thing, that if it is not visited of this particular cell is false, then we will call one function, let's say helper, and let's see the constraint. So grid of I has a value of 10 power 6 at max value, and m cross n has a 10 power of 5 value. So if you multiply these two, which means let's say all the in the entire grid all the values are positive integers, and all are having 10 power 5 numbers, and 10 power 6 numbers, and its size is 10 power 5. So if you try to represent these sum in integers, then it will overflow, because it is 10 power 1. So we'll have to take long. So I'll take long sum I'll be calling helper function. I'll be passing ij, which is basically the cell number, and I'll be passing grid. I'll be passing visited array. So I'll write this helper function. So now I'll find it. If sum modulo if it is equals to 0, then I'll increase the count. Count is basically which keeps track of the answer. So initially it is 0. If the island sum is divisible by k, then that island is our answer. So that's why we're increasing count by 1, and at the end we'll have to return this count. Now let's try to write this helper function. Yeah, so int I, int j we have, and this grid we have. Let's pass this grid by reference only, because every time we call the function, that will the grid is passed by reference, so that values are not copied. So memory optimization is done here. Now let's take visited vector, which keeps track of which all cells are visited. Okay. So whenever we come into a particular cell, so we will mark that cell as visited. Okay, yeah, because from here we will be entering into this helper function whenever that cell has value, positive value, which means it is a land. So whenever we come to, let's say, land, so in that case we'll mark it as true, and we'll take one some variable whose value initially will be 0, and I'll be moving this way, upward, right, down, left. So how do we find upward? So if I minus 1, if it is greater than or equals to 0, so which means boundary conditions are met, that I'm basically doing. And we'll have to find if grid of I minus 1 comma j is greater than 0, which means it has a land. Also it has to be not visited. The cell above cell, what from the current cell above cell whatever we're visiting, so that cell has to be not visited. So in that case we will go to that cell and try to find the again all sum cells values, that will do it. So we'll move I minus 1 j and grid visited. Now we'll take care of the right. So right is basically column, so j plus 1. If it is less than grid of 0 dot size, and grid of j plus 1 comma j, sorry, this is I and this is j plus 1. If it is greater than 0 and it is not visited, I comma j plus 1. So in that case again we will move to the right side and we'll call this helper function j plus 1 grid visited. Now we'll try to move downward. So downward will be I plus 1. If it is less than grid dot size and grid of I plus 1 comma j is greater than 0, which means it is land and it is not visited, then only we'll visit there. We'll visit to the downward cell. Sum plus equals to helper I plus 1 comma j comma grid comma visited. Now we have checked upward, right side, downward. Now we'll have to check leftward. So left is basically the column, so which is j, and left side means minus we'll have to do. If it is greater than or equals to 0, which means it lies in the boundary, and grid of j minus 1 I comma j minus 1, if it is greater than 0 and it is not visited. Then we will go to the left side, I comma j minus 1 comma grid comma visited. So now at the end we'll have to return, since we are on the current cell, that value will have to return current cell value, and like from this function, from this if condition we were going to the land, so we are on the land. Now we are moving to all 4 directions, and we are finding the those cell values, so which will be in this sum variable, those the cell values. So but from this particular cell, this is grid of I comma j plus sum will be returning. Now let's try to run the code. Yeah, it is running fine. Let's try to submit the code. Okay, it is overflowing. Yeah, as I said, like where is it? So this is basically it will flow out of bound. So we'll take this long. So in order to define that, hash define ll long. Uh, so this sum value will be long value. Yeah, this is fine. We'll write here also long. Let's try this case also because it was overflowing. Yeah, it is running fine. Let's try to submit the code. Yeah, it got accepted and it beats 100% of the user. So if you try to analyze the time complexity of this, so this loop is taking m cross n time, and helper function we are calling, right? So at max, like this helper function, let me take you to the board and explain. So the outer for loop pod, we have two for loops that will take m cross n time, and you may be thinking this for every cell we are calling that helper function. Again, that helper function at max, let's say it is starting from here, and I mean this grid has all land values, so it will go to all the cell, right? It will visit all the cell. So you may think of it is like m cross n, so m square cross n square, but it is not true, because the first cell, let's say in worst case, all in worst case 1 2 3 4, let's say all the cell values are having land. So whenever we are calling the first cell, this will call the second, third and fourth, I mean all the cell it will call. And now since all the cells are visited, and it will come out of the this helper function, and whenever you call this, you will not be calling for this helper function. So basically the outer for loop is taking m cross n time plus at max the helper function will be called m cross n times. That's it, not more than that. So the time complexity is basically 2 into m cross n time complexity of. And yeah, if you see space complexity here, we are using one visited vector which is m cross n, and we are calling helper function. Again at max it will go till m cross n. So yeah, space complexity is also m cross n. So yeah, thank you guys for watching the video.